Hello friends, welcome back. In this tutorial we will study about system resource allocation graph. This system resource allocation graph is a directed graph. So it consists of vertices and edges. So these vertices they are divided into two categories. One is those vertices which represents active processes in the system. Another category is of those vertices which represents resource types in the system. So in a system resource allocation graph, the process is represented by a vertex, right? It is represented by a vertex by a circle, right? And the resource types, right? They are represented by rectangle, right? So they are the vertices which are represented by rectangle. Resource types are represented by rectangles and the processes are represented by circles, right? So this type of vertices are circle and this type of vertices which represents resource types, they are rectangle, right? Now what happens? A resource type may have more than one instances, right? Suppose the resource type is printer, right? So we may have two printers or we may have three printers, right? So what happens in a system resource allocation graph? The resource type printer, it will be represented by a rectangle. Now how we will represent that there are three instances of printer? It means there are three printers. So to represent this, what we will do? We will make three dots, right? We will make three dots in the rectangle, right? So it represents that there are three instances of this resource type printer, right? Suppose the resource type is Ri, right? So in system resource allocation graph, this resource type Ri, it will be represented by a rectangle. Suppose there are two instances of this resource type Ri. So to represent it, what we will do in this rectangle, we will make two dots, right? Now edges. So what happens? There are two types of edges. One is assignment, right? One type is assignment edge. Another one is request edge, right? So what happens? Suppose consider this process P1, right? And there is a resource type Ri. So in system resource allocation graph, suppose this process P1 is represented by this vertex, right? Which is represented by a circle. And suppose this resource type Ri, it is represented by this vertex which is a rectangle, right? Now this process P1 is requesting an instance of resource type Ri. So how we will represent it in a system resource allocation graph? We will represent it by making an edge from process P1 to resource type Ri, right? By making an edge from this vertex to this vertex like this. So this edge represents that process P1 is requesting an instance of resource type Ri. So it is a request edge, right? Suppose this resource type Ri, it has three instances. So how we will represent it? By making three dots in the rectangle, right? So these three dots represents that there are three instances of this resource type Ri, right? Now suppose one of the instance of resource type Ri, it is assigned to the process P2, right? So in this system resource allocation graph, what happens? This process P2, it is represented by this vertex, right, by this circular vertex. So how we will represent in this system resource allocation graph that an instance of resource type Ri is assigned to process P2. For this we will make an edge from one of the dot of this rectangle to this circular vertex which represents the process P2, right? So what this edge represents? This edge represents that one of the instance of resource type Ri has been assigned to process P2, right? So such type of edges are called assignment edges, right? This edge is an assignment edge, right? Now suppose in the system all the resource types, they are having only one instance. So in that case, if there is a cycle in system resource allocation graph, then this cycle represents that there is a deadlock, and all the processes which are involved in this cycle, they are said to be in deadlock, right? Now see this example. Suppose this is the resource type R1, right, and this is the resource type R2, right, and this is the resource type R3, right, and these all resource types, they are having only one instance. So we will make only one dot in these rectangles, right? Now these are the processes P1, P2 and P3, right? Now this process P1, it is requesting for an instance of resource type R1, right? So I have drawn an edge from process P1, right, the vertex which represents the process P1, to the rectangle which represents the resource type R1, right? Now suppose this instance of resource type R1, it is assigned to the process P2. So what I will do to represent this, I will draw an edge from this dot to the vertex which represents the process P2, right? And this process P2 is requesting a resource of type R3. So to represent this, I will draw an request edge, right? I will draw a request edge, right, from process P2 to resource type R3, right, from the vertex which represents the process P2 to the vertex which represents the resource type R3. Now this instance of a resource type R3, it is assigned to process P3, right? See this vertex represents the process P3. So what I will do, I will draw an edge from this dot to this vertex which represents the process P3. Now suppose this process P3 is requesting an instance of resource type R2. So to represent this, what I will do, I will draw a request edge from vertex which represents the process P3 to the vertex which represents the resource type R2. Now suppose this resource type R2's instance is assigned to process P1. So I will draw an assignment edge, right, from this dot to the vertex which represents the process P1, right? Now here there is a cycle, right? Now see in this system resource allocation graph, there is a cycle. So what happens here? There is a deadlock. The processes which are involved in this cycle, they are in deadlock. So here process P1, P2 and P3, they are in deadlock. You can see this process P1 is waiting for process P2 to release the instance of resource type R1. Similarly, process P2 is waiting for process P3 to release the resource of a resource type R3, and this process P3 is waiting for process P1 to release the resource of resource type R2, right? So here there is a deadlock, right? Now see, if in the system the resource type has more than one instances, then in that case the existence of a cycle in a system resource allocation graph does not mean that there is a deadlock, right? So what happens in this case, if a resource type has several instances, then in that case the existence of cycle is necessary for deadlock, but it is not sufficient condition for the existence of a deadlock. Now for example, suppose there are two resource types R1 and R2, right? Both of these resource types has two instances, right? This vertex represents the resource type R1, this vertex represents the resource type R2, right? Now this is the process P1, right? This process P1 is requesting for an instance of resource type R1, right? And one instance of resource type R1 is allocated or assigned to process P2, right? Another instance of resource type R1 is assigned to process P3, right? Now this process P3 is requesting an instance of resource type R2. One instance of resource type R2 is assigned to process P1, and another instance of resource type R2 is assigned to process P4, right? Now see this system resource allocation graph. The cycle exists in this system resource allocation graph, right? But the processes which involve in this cycle P1 and P3, they are not in deadlock, right? Now see here, this process P3, it is requesting for an instance of resource type R2, right? And one instance of resource type R2 is allocated to process P4, and process P4 is not waiting for anything. So what will happen after completing its task, this process P4 will release the instance of resource type R2, right? And then that instance of resource type R2 can be allocated to process P3, right? Similarly see here, one instance of resource type R1 is allocated to process P2, which is not waiting for anything, right? Process P2 is not waiting for anything. And here process P1, right, it is requesting an instance of resource type R1, right? So what happens here, process P1 is waiting, right, like process P3, right? So but the process P2 is not waiting for anything. So after completing its task, it will release the instance of resource type R1, right? And then that instance of resource type R1 can be assigned to process P1, right? So here cycle exists in this system resource allocation graph, but the processes which are involved in this cycle, they are not in deadlock, right? So what happens if there are more than one instances of a resource type, then in system resource allocation graph, cycle doesn't mean that there is a deadlock, right? Cycle is necessary, but it is not a sufficient condition for the existence of deadlock.